everybody, very good morning to all of you. Hope things are going smoothly and you all are studying properly at your home from this operation. Student, in last video what I have uploaded day before yesterday, in that video we discussed some property of lenses and lens maker formula. I told that this equation or this video are very important for the board exam because several time a question are framed on that topic only. Now I am sure that you all become familiar with the question which are framed on that topic, and I am sure that you are become comfortable to solve such problem also, which are framed on the basis of lens maker formula. Assuming that these all thing has been done till now, let us start our discussion to the next level, to the next topic, that is image formation by the lenses and how different images form on the basis of position of the object by the both type of lenses, and further we will discuss about the image formation of combination of lenses, and we'll then discuss about the question which can frame on the topic or which already has been framed or had been asked by the CBSE in different exams. So let us start our discussion with the image formation by the lenses under the topic of refraction of light in ray optics. And first of all we are going to take the convex lens. It means image formation by the convex lens. There are some cases, I am sure that you all already has been seen of this topic, of this phenomena. Maybe you have performed the activity based on that image formation by the convex lens, and you already known or aware how does image is formed by the convex lens. So I think this session is almost a brush up type of session, and I just want to brush up these all things and just want to discuss what is the important term in the formation of image by the different lens, and which we are going to use in our different optical instruments, say telescope and microscope, in further topic. So let us take first of all image formation by the convex lens. First case first. Case first. There is some rules to required to deal with the how does image is formed by a lens. Let the some rules. One, you must have remember about the optical center. If a ray of light is incident through the optical center, it goes undeviated after the refraction, irrespective the type of lens, whether it is convex lens or concave lens. See, suppose we have a convex lens like that. We have discussed that a point on the principal axis at which if a ray of light is incident, it goes undeviated after the refraction. So this is the point that is called optical center. If a ray of light is incident on it, after refraction it goes through without deviation or undeviated. Whether any type of lens it is, suppose we have concave lens like that. This is the concave lens, and a point this is, if a ray of light is incident on it, it goes through undeviated after the refraction. This is the first rule. Rule first, to deal with the image formation by the lenses. Second, in convex lens, if a ray of light is incident parallel to the principal axis and very close to the principal axis, after the refraction it goes through the second focus, like that. Suppose we have a convex lens like that, and this is the principal axis. If a ray of light is incident in this way, it means parallel to the principal axis and very close to the principal axis, after refraction it goes through a point that is called second focus. In case of concave lens, if same phenomena is repeated, it means a ray of light which is incident on this plane, on this concave lens, parallel to the principal axis and very close to the principal axis, after refraction it goes through like that, and if we retrace back, it meet a point in same side, that is called first focus of concave lens. This is concave lens and this is convex lens. These all things we already have discussed in last two video, I remember, and that. So by taking these two phenomena, it means ray of light if incident on different lenses in this way and their path after the refraction is something that what we have discussed before are going to be used in formation of image by a lenses. Now we are going to discuss first case. Suppose with convex lens. Suppose we have a convex lens like that, in this way. This is convex lens and this is the principle of convex lens. This is the optical center and this distance, this is called first focus, and at the same distance this will be second focus 2f, an opposite side of the lens, this is called second focus, and at equal distance this is 2f of second focus. Suppose an object is placed at infinity, this way. This is the object which is placed at infinity. Then we can say the ray of light which will incident on this lens, it means first surface or first plane of this lens is parallel to the principal axis in this way, parallel to the principal axis. And see there, if a light which is incident on the lens and parallel to the principal axis and very close to the principal axis, after refraction it goes through a point that is called second focus. It means after refraction it goes through that point in this way, and this will be the image of the object which are at infinity. Now we just want to discuss some terms. It means the position of object is at infinity. It means u at infinity. Image is formed v at f. Size of image, diminishing, बहुत छोटा है, diminishing, nature of image, real and inverted. One more term let's discuss here only, that is magnification. Magnification is small, represented by small m, and equal to the height of image upon height of object. Height of image is diminishing small, point size almost, and height of object may be anything, because it is at infinity. The ray of light which are coming from is parallel to the principal axis on the lens. So magnification is much less compared to that of 1, because this value is approaching to 0, almost approaching to 0, and this value has some certain value h naught. So the value is very small, therefore magnification we can say is very less compared to that of 1, minus 1, because it is inverted. So the distance which are measured below the principal axis is always negative, what we have discussed before, and the distance which are measured above to the principal axis, this will positive. So this is first case in which if an object is placed at infinity, it may, or we can say beyond the 2f, which will be considered at the infinity, the ray of light which are coming from is parallel to the principal axis, therefore image is formed at the focus. The size of image is diminishing small, nature of image is real and inverted, therefore magnification is much less compared to that of 1, and negative sign represent that it is inverted. Clear? So take second term. Case second. Suppose again we have lens, a convex lens, and this is the principal axis. This is convex lens. Again this is the optical center, and this distance is first focus. This is 2f, and this distance is again f, and this one is 2f, as before we have assumed. Now take the object somewhere in between infinity and 2f. It is all again beyond the 2f, but in between infinity and 2f. Let's say proper distance in this way. This is the position of image AB. It is in between infinity and 2f. It has got a certain position. Now take those rules. 1, from point A, take a ray of light which is parallel to this principal axis, and after refraction it goes through the focus like that, and a ray of light from same point A try to incident on the optical center, which go through undeviated after the refraction like that, this way. Both are intersect at a point here, which will be the image of A, and it called that A dash or A prime. Now just imagine the point B, the ray of light which must be incident along this principal axis, and obviously it incident on optical center. After the refraction it again goes undeviated, and the image of point B is lying over this principal axis, and anywhere just draw a perpendicular from the A, and we will get a proper image here, that is called B prime. So A prime B prime will be image of the object AB, which are at in between 2f and infinity. Just write down the same information what we have discussed in first case. One thing, the position of object is in between 2f and infinity. It means u is somewhere in between 2f and infinity. Okay. Image distance, it means image is formed at in between f and 2f, in between f and 2f, opposite side of the lens, opposite side of lens. The nature of image we can see, this is the real image inverted. How real image is formed? Just imagine the situation, which type of image is called real image and which type of image that is formed by the lens or are called virtual image. Take a screen somewhere in between here, lens and the infinity of another side of image, and if we got any image on this screen, if we are moving, we can adjust the screen in between infinity and the second plane of the lens. If we got the image somewhere in between, this image is called real image. If we do not get any image on the screen which are placed behind the lens, so this is called virtual image. If image is formed on the screen here, anywhere, then this image is called real image. If image is not formed on this screen, the image is called virtual image. So this is again real image inverted and size is small. Size of image is small, is smaller than object. Second thing, nature of image, we can see here nature of image is inverted and real because it can be obtained on the screen which are opposite side of the lens. So magnification, m is equal to minus h of image upon h of object, negative sign. Why has been taken with the height of image? Because this length or this distance is below the principal axis. By the sign convention, all the distance are measured below the principal axis would be negative, and all the distance which can measured above the principal axis, that is positive. So to think from the magnification, we can say here one thing, it is magnification is less than 1, minus 1, because height of image is less than height of object, yeah, size of image is less than size of object, and because of inverted, so negative sign will be inserted before the 1. So this is two cases when how a how a convex lens can form the image. Let's take one more example. For that we have to erase these all things, तो इसको हम रफ करेंगे. Case third. Suppose we have a lens in this way. This is the optical center, and this is F, this is 2F, this is F, this is 2F. This is F, this is 2F. Case third. Let object place at 2F, exactly at 2F. This is. Again, in the same way, take two rays of light, one each which are incident on the first plane of the lens, which is parallel to the principal axis, in this way. After refraction, obviously it goes through the focus like that. And second ray is considered to be incident on pole. After refraction, it goes through by undeviated in this way. After refraction, it goes through undeviated by this way. Both rays are incident this point. So this is the image of A, that is called A prime. And in the same way, the image of point B is somewhere on the principal axis opposite to the lens. And if we find that point or draw a perpendicular from the principal axis to the point A prime, where both rays are intersect to each other, we will get a image like that, A dash and B dash. And if we discuss about the nature and property of this image, we will get that size of image is exactly same the size of object. It is inverted and real. So two things what we want to discuss here. One thing, the position of object. It is at 2F. Position of image. It is also 2F opposite to the lens, opposite side. Nature of image. We can see the nature of image. It is real, inverted, and same size. So magnification, we can say h of height of image upon height of object. Negative sign will take with the sign height of image because it is formed somewhere below the principal axis. So negative sign will represent here. So magnification exactly is equal to 1, or we can write -1. Negative sign represent that image is inverted. This is third case. Fourth case. Next case. Suppose this is a convex lens. And this distance suppose takes as F. Same equal distance. This is 2F from the pole. This is F. This is 2F. Now, just change the position of object and put the object in between F and 2F somewhere here. This is AB. The position of object is somewhere in between F and 2f. Again take the two rays what we have taken in before all cases. One rays which is parallel to the principal axis and very close to the principal axis. After the refraction it goes through the focus like that. Second thing, a ray of light again take which are incident at pole like that. After refraction it goes through undeviated and somewhere meet or intersect here. So this is the image of point A, that is called A prime. Just drop a perpendicular from the principal axis to point A, we will get the image of AB, A prime, B prime, in this way. Again we can write the all information about the image that has been formed by the this lens. If object is placed in between f and 2f, the image is formed beyond the 2f and the size of image is now larger compared to that of size of object. It is inverted and real. So we can write all the information about the image formed by this lens. First thing what we want to write, that position of object. Position of object. It is in between f and 2f. Between f and 2f. Position of image beyond 2f. Beyond 2f. Nature of image. We can see nature of image. It is real, inverted, enlarged. So magnification can be right height of image upon height of object. Negative sign will be inserted here because the image is formed below the principal axis. All the distance which are measured below the principal axis are taken as negative. So magnification again comes negative, and it more than the 1. So magnification can write it is greater than 1 with the negative sign. One or two cases are remain to discuss. So I just want to erase these all things first of all. Then we'll discuss further two cases. So I want to erase these all things. Okay. Take some remaining cases. Case 4th has been discussed. Case 5th. Suppose we have a convex lens, a thin convex lens. Always thin convex lens will be taken. This is optical center. Take a proper distance where parallel light after refraction go from there. This is f, and same distance of f, it is 2f. In opposite side also, this is f and this is 2f. Now take the object at exactly at f, like that. This is the position of object which is exactly at F. Again take same type of rays. One ray which is incident first plane by first plane parallel to the principal axis and close to the principal axis. After refraction it goes through the F. It means opposite side of focal length, this way. Second ray, it is from it is from optical center like that. After refraction it goes through undeviated in this way. Now two parallel rays has been obtained. Two parallel rays. Which will meet at infinity. It is considered to be meet at infinity. Somewhere like that. Suppose this is the position of infinity. Here these all things mean infinity. So image is something like that. If the position of infinity is that, and it always can obtain on the screen, so it is real image. So now we are able to write all the information about this image which has been formed by this lens if object is placed at focus. See the position of object. Position of object is at F. Position of image infinity. Nature can be discussed. Nature of the image is real, inverted, enlarge. ऑब्जेक्ट साइज से बहुत बड़ा होता है. मैग्निफिकेशन, हाइट ऑफ इमेज अपॉन हाइट ऑफ ऑब्जेक्ट. It means magnification is much greater than 1 and negative sign represent it is again inverted. Okay. Sixth case, that is last case, case 6. Suppose we have a convex lens. This is the principal axis. This is the optical center. Take a distance. If a ray of light is incident from, after refraction it goes parallel, and at the same distance, this is 2f, this is f, and this is 2f. And here the first focus can be drawn at the same distance. If a ray of light is incident parallel, after refraction it goes through the point that is called first focus, and take the same distance further, it is 2f. This is f and this is 2f. What we have just discussed in all the 5 cases. Now let the position of image somewhere in between first focus and optical center like that, this way. Again take a same type of ray. One ray is incident parallel to the principal axis and it is very close to the principal axis. After refraction obviously it goes through the focus in this manner. Again take another ray which are going through the optical center, and after the refraction it goes through undeviated. After refraction it goes undeviated. two diverging rays has been obtained. Two diverging rays has been obtained. Which will never meet any point. Two diverging rays is obtained which will never meet at any point, जो कभी नहीं मिलेंगी कहीं पर भी. Draw back the rays in this way. And they are meet somewhere here, and this will be the image of A. This is A prime. Drop the A perpendicular to the principal axis, and this will give you B prime. It means image of this point. Now the image is formed is same side. Obviously it is enlarged, but if we put a screen here and here anywhere, we would not get any image on that. So it is it is obviously virtual image, because it cannot be obtained on the screen if we put anywhere in between infinity to the optical center opposite side of the lens. So it is virtual image. First of all, only one case in which virtual image is formed by the convex lens, if the object is placed somewhere focus and optical center. We can say this is the image A prime B prime, which is enlarged, virtual and erect. It is not inverted. So we are now able to write all the information about this image. First step, position of object. Position of object in between F and optical center. Position of image same side of image of lens, सेम साइड ऑफ लेंस. कहीं पर यहीं पर सेम साइड ही बनेगा. नेचर इरेक्ट, virtual, because it cannot be obtained on the screen. Enlarge. Magnification, we can write magnification of this image in this situation. M is equal to height of image should be taken positive, because it formed above from the principal axis, divided by height of object, and we will get this is the M is much greater than 1. So this magnification also greater than 1, and positive sign represent that image is erect. So these two cases are very important cases for further study, in which we will discuss about the optical instrument, say a telescope, microscope, etc. So this is the two important situation when image is formed by the convex lens, and this is all the information about the image formed by the convex lens. and just want to summarize all the cases at one figure, and then we'll discuss about the image formation, image formed by the combination of lens. I think video is going to be lengthy, so by the summary of these all image that formed by the convex lens, I just want to, over this class, next class I will discuss about the combination of lens and different cases and different illustrations. Let's take a summary, take a view of all cases what we have discussed before. Suppose we have a lens, we suppose we have a thin lens like that. This is the optical center, and take a point. If a ray of light is incident from, after refraction it will goes parallel to the principal axis. This is f, and the same distance we marks the 2f here. If a ray of light is incident parallel to the principal axis, after refraction it goes through a point that is called first focus f, and take the same distance further, this is 2f. If an object is placed at somewhere infinity, the first case we have discussed, AB an object which is at infinity, the image is formed at focus. This is the first case. This is the position of image. Size is point size. This is real image inverted. Magnification is much less compared to that of 1, and it is represented that much less than compared to that of -1. Negative sign represent that it is inverted. Okay. Take second case. Now put the object in between infinity, somewhere in between infinity and 2f, like that here. This is the second position, second case what we have discussed. The image is formed is somewhere in between f and 2f. This is a smaller size compared to that size of object. This is the second situation, this is first situation, this is the second situation that we already has been discussed. Now take the object at 2f. If object, place the object as 2f, this is the third case what we have discussed, and after refraction the image is formed at 2f, and height of the image is same, so magnification is -1 is equal to, magnification is right -1, negative sign represent that image is inverted, and all the image which are formed on the screen that put in opposite side of the lens, that is real image. So all three cases what we have discussed, this is the real image. Again put the object somewhere in between f and 2f, that is fourth case what we have discussed. This is the fourth case. The image is formed is beyond the 2f in opposite side of the lens, and now image is something enlarged or larger compared to that of image. This is the fourth case that has been discussed. It is also real image, it is also inverted. Magnification in this situation is m is greater than -1, negative sign represent that it is inverted. Magnification I can represent here only. In this situation magnification m is less than -1. In this situation m again is less than minus 1. In third situation, magnification is greater than minus 1, sorry, equal to the minus 1. Third case, equal to the minus 1. And in fourth case, magnification is greater than minus 1. And again, if the object is placed exactly at the focus, secondary focus or second focus, the image is formed at infinity, somewhere like that. This is the fifth case that has been discussed. This is the position of image on fifth case. The magnification m is much greater than 1, and negative sign represents that it is all again inverted, and it is real because it can be obtained on the screen that can put in between on the infinity. And last case that has been discussed here only, if object is placed somewhere in between optical center and focus, the image is formed somewhere same side, and it is virtual image like that. It is erect and enlarged. The magnification in this case n is greater than 1. Positive sign represent that it is erect, and only one case in which virtual image is formed by the convex lens, that is if object is placed in between, somewhere in between optical center and focus. So these all the cases in which image is formed by the convex lens. One thing has remains to discuss about the image formation of lens, that is image formation of concave lens. We'll continue this process in next video, and further we will discuss about the image formation of two or different lens if keep in the contact, and the illustration based on that. So this is a theoretical class, and obviously you all have seen before in class 10th. That's why I take so fast in this way. So let's enjoy to study with you and be comfortable.